Yep, so it's really nice to be here again after last year. We really enjoyed a conference in Aviemore, and it's great to be again in this community together with all the peatland people. So we've come a long way in a year, but just shortly. So the thing we pride ourselves, it's a mixed team of ecologists, remote sensing people, AI people, and businessmen. What we do is we take very high resolution imagery, 30, 50 centimeters from satellite, or 5 to 15 centimeters from multispectral air photography. And we use deep learning AI, which is actually, it has been around for quite a long while. It's not ChatGPT, it's been used for image classification for a long time, but it just became more efficient recently. And then we produce a map and we quality check it with our ecology team. So you can get the map which is validated against the field data as well. These data could be sometimes more granular than the maps done by ecologists on the ground. So you see, here you can see some of the purple spots are the shrubs that the field surveyor has missed. Maybe they didn't have access, maybe they didn't have time. So because the tree recognition, shrub recognition is very simple now with deep learning AI, we can save time for the ecologist in the field. So they just need to label species, for example, but they will have all these contours already on the tablet or the printout. We use mostly so we use imagery which is much higher accuracy, higher resolution. It's commercial imagery, starting with 5 centimeters for air or 30 centimeters for satellite, but 15 centimeters is coming. So we also use the 10-meter data, but only for providing the background, the context around the site of assessing basic connectivity, but it is basically very precise data that can be used for local applications at the site level. And our main products are about habitat mapping, including distinctiveness and BNG value of the land. This is where we come from, and this is both for rural and urban habitats. And we provide them via online platform, and that includes API, so you can either do it manually, draw your area, upload on the platform, or you can upload hundreds of sites at the same time with API. The new products that we developed over this past year is the instant habitat mapping at very detailed level. So this is called TrueSight. So far it only works in the UK, but we are developing TrueSight global as well. So this is broad habitat categories, but with very high granularity. And this has been used by many customers for selecting their sites for acquisition, because they can very quickly assess the biodiversity uplift potential, and depending on their needs, they can select either higher or lower uplift. And that also includes distinctiveness as well. And then the TrueSage, which is the main product in respect of peatland, because we are aiming to assess peatland condition, it takes longer, it takes probably about 10 working days, sometimes less. And it has the quality control from a human ecologist at the output. So that could also include the biodiversity units. In this case, the example is for places outside the UK. So we also developed a global biodiversity unit system, which is based on IUCN ecosystem typology. So where we cannot use the UK biodiversity units, we can use our own for universal comparisons between sites in different companies in different countries for one company, for example. And of course, well, I don't need to preach to the choir, but for monitoring, remote sensing is really good. Once you have your model validated against the ground data, you can do monitoring much more efficiently, so you can save a lot of time on the ground for the ground crew. And we started working with relatively simple peatland products initially. This is a site in Ireland where we had a very simple classification with brown for bare peat, dark blue for water, and then 2 classes for woody and non-woody green vegetation. This is a restoration project where the company wants to know how successful is restoration going. And now we're also assessing whether we can map drier peat or moister peat, wetter peat for them, so they can target the restoration on the big areas they have. We've been also recently doing some more peatland mapping in Scotland, and this is now at the level of dominant species, so we can train our model. We trained our models to recognize Kaluna dominated bogs and Juncus, Erioforum, and Sphagnum is coming. It just in this area there wasn't much of it. And then this is also ericaceous vegetation, and of course the bare peat, which is quite easy to detect, the eroded gullies and hugs. And this takes us to the project that we are developing over the past year, which is the Innovate UK funded project called Eco-Patterns. It actually focuses on two types of habitats, both peatlands and open mosaic habitats on former brownfields. But of course here we'll focus on peatlands. And the most important part we are trying to do is to assess peatland condition. So we work together with Richard Lindsay using his condition matrix data on the ground. So as you know, this condition matrix has type of vegetation on the x-axis, and then it has microterrain, microtopography features on the y-axis. And if most of your points on the ground are in the green, it's probably the best condition peatland. If it's in the red, it's heavily degraded, probably not recovering. So this is already a rapid way to assess peatland condition in the field. But what we are trying to do is to train on lots, on hundreds and hundreds of these condition matrices from different parts of the UK to translate it to the language of image processing, image recognition, and AI, and produce simplified but universal peatland condition assessment for the UK. It will be either a host of models for different regions, but what we're trying to do is to make a universal model that will be applied for all parts of the UK. And currently this is the data, the ground data that we have from different parts. For Northern Ireland, actually we are going to acquire some more data in Garonne Plateau in a few days. Hopefully the weather will be good for that over the weekend. And originally, so the way we planned this data, in the yellow points, we're collecting our own data, and they have been selected in mostly not very damaged locations, which are not being restored. And then also, there are the red dots, which are peatland code projects running at the moment, and we are reaching out to developers of those projects, whether they use, if they use peatland condition matrix to collect the data, then we are trying to develop collaborations to use that data and produce trial maps for them and validate them. So the project is currently still translating the data we already have into the model. So we will hopefully have the results by January next year, when it is about to end. So what we are trying to do is to have a validated monitoring tool, which could be applied for peatland code projects. So we have to ensure it's heavily validated with existing ground survey data. And then we hope it will eventually go on a peatland code and woodland carbon code website as one of the tools available to use for this. So it's not going to replace all the ground surveys, of course, but it should greatly speed up the validation verification surveys. And eventually, we also hope to be able to do baseline surveys, or at least, again, replace some of the work of the ground crew. Hopefully 67% of the time can be reduced. Some screenshots, some photos from the field in northern Scotland this year. And now coming to our second part of the workshop today, we are hopefully going to Ballonahona Bog to experience some rain and some wetland. And what we tried to do for this bog, we were able to acquire different kinds of images. So there we'll be testing this blue part of our project using different resolutions, seasons, and spectral coverage. So for the bog, first of all, we acquired digital multispectral photography for this year, but it was done in April, so quite early in the season, in 4 spectral bands. So this is natural color, and we are going to access it from the south, just above the scale bar. This is the same image, but in false colors. Vegetation is in red, and you can see the reddish, dark red patterns on the actual bog in the middle are mostly dwarf shrub vegetation, while the grassy vegetation is more green-brown color, and there are some bright green areas, which include sphagnum revegetating, sphagnum fuscum revegetating the recently restored or recovering lands. The other image we have, it's a bit older in terms of time. It's from 2019, but it's a more interesting season because in September you see more variety of color between the different peatland plants. It is 50 centimeter resolution, so a bit worse than the digital photography from the plane compared to 14, but it has 8 spectral bands. So this is again a natural color, and Balonachone bog is always very dark in the middle, but you can still see a bit of green, which is again mostly dwarf shrubs on the high areas. And this is combination of the infrared bands. So because it has 8 spectral bands, it also has 2 near infrared and a red edge band. And this is actually quite good to detect the water in the near surface layer. So we produced some, first of all, we produced the shrub and tree vegetation marks with our tree recognition model. And then within that, you can see different colors. So this is a preliminary model, in this case, based on the visible layers, on the blue, green, and orange. Actually, the best approximation what we see with our eyes. So it's focused on the color. And in this case, we see the orange and brown dots are the dwarf shrubs on higher ground, and then the lighter green is grassy vegetation on lower ground, and the blue near the point in the south where we will access, it's recently revegetating sphagnum and also Eriophorum next to it. There are some areas on the south border which are also bright color because of the clouds, but we'll avoid those. And that's the classification of the near-infrared bands. And in the blue here, you can see the drainage patterns, which are more hidden in the visible, but you can see the different drainage areas coming down to the southeast. So we're going to explore this more on the bog today with printouts of these maps, and we'll be collecting the peatland condition data in some of the spots we selected, pre-selected, and looking at the classification maps. Before when we were planning this session, we talked about prices and costs and advantages of different technologies. So this product, when it's developed, is going to come under our true sage pricing. So it will be going down rapidly depending on the hectares. So it's starting with 200 for 1 hectare, but then it will be, when I go to 2,000 hectares, it will be £2 per hectare. So the bigger is the bog, the more cost efficient it becomes. So this could be it could give you some sort of idea how it could save the costs compared to the field survey. And finally, we will be running a workshop in early November, where we will showcase the first outputs of the peatland condition mapping. And we would like to hear from you as users, what are the needs that we can satisfy with this product, and what are the other needs we could try to look and model and map for you with AI and very high resolution data. So please use the QR code and please sign up. And it's free for all, and we'd really love to hear from you about your needs and how we can adapt this product with very high resolution data to your needs. Thank you.
Thank you, Olga. Is anybody got any questions?
Thanks very much for the really interesting presentation. I'm Kevin Duncan from the National Trust. But it's hard to get your head around everything that you've put across there very quickly. It's quite like mind-blowing. And if I was an ecologist, I'd probably be quite worried now for my job, if it is as good as you say it is. Can it define different grassland types? Or is it more fit to tell the difference between grassy vegetation and woody vegetation? Or do you think it could get down to different grassland types in the future? Or maybe that's already there?
Not really. So deciduous vegetation and grasslands are notoriously difficult to identify between themselves with multispectral and even hyperspectral imagery sometimes, because it's a mixture of the chlorophyll signal and also you have a species information and the state of vegetation information there, and also the moisture content. So we can identify some species, so sphagnum, especially when it's bleached, dry, shows up. You can identify some species which are very moisture-loving, like Eriophorum, Angustifolium, because of the combination of water and the plants. So it's contextual information, but we will not be able to identify all the plants, and we will really need the ecologists to go and look at specific species when it's required for the mapping. So we are not going to replace 100% of the work, okay, maybe 60%. So what we want to do is to give the ecologist a ready map that they need to label and add information to, but they already have the contours, so they don't have to map them on the ground. And they have the basic idea. And then what I haven't touched upon very much, but we are combining the colors, which have been traditionally used in remote sensing, and patterns, because different patterns of ponds, for example, of natural water ponds will be characteristic of natural healthy peatland, and of disturbed peatland there will be different drainage pattern. So patterns also are stable through the season, so we can use that information, and then we also use colors of vegetation from the optimum season to do some species recognition. We can also add LiDAR to the equation when we have the LiDAR data, and it makes it even more reliable because there is more information about microtopography, but that will depend. So what we are trying to do is to be universal for quick assessment, so that then it will be satellite data and a model trained on similar environments on field data, but then it could be also more granular when we have a site with more data. So for example, for Balunahona, there is also LiDAR data set. If you can get access to that, we can improve on that. Not replacing the ecologist, no way.
Could it be programmed at some point, like, you know, we all have individual DNA? Could each plant have a signature that you could pick up? What I'm thinking about, we have a big problem here in Northern Ireland in agro-environmental schemes. It's very costly to have people going out on the ground to monitor, particularly, you know, with farmers and things. And if you could have a model that could pick up key indicator species for example, it would really speed that process up and make it more cost effective. So in that situation, the farmer would get more of the money rather than, say, a lot of the admin and sort of administration kind of thing. So that would be a useful thing if it, you know, it didn't have to identify everything, but it had key indicator plants to tell the difference from an improved grassland moving towards semi-natural species, which sort of long term.
Yes, well, for peatlands, of course, we already have the key indicator plants in the matrix, so we are trying to see which ones we can identify. And there are many species of sphagnums there, and we only can identify the group of sphagnums. For other, like we say, for more general habitat mapping, it does depend. Sometimes you can identify the species, but it's more, again, about the patterns, because the improved grasslands will have a more homogeneous pattern than the more natural grassland, which have a number of tussocks and other things. So yes, we can do it at the level required for biodiversity net gain. We are aiming to do that. So we have several dozen classes required for UK habitat classification already in our model, and we are trying to develop more. We can map hedgerows, for example, but again, not to species level. So there will be still some work from ecologists required, but yes, we can identify improved grasslands and the natural grasslands already from the imagery and the AI we have.
Thank you.
Hiya, I was wondering how well you are able to do with the three-dimensional element of peatland vegetation. So you might have an understory of sphagnum that's covered by sedges or heather. Is that something your model is able to distinguish, or is that granularity only determinable by the ecologist visiting the site?
So to some extent, because if certain plant communities occur in certain microtopography features, so with 14 centimeter data, we can see tussocks and hummocks, and then from the species we see on the top, because basically we see a horizontal projection of everything onto our image. we do not see through the plants, but typically you will have not very high coverage of the sedges. You will still see the sphagnum through. So still, if it's 30 centimeter imagery, you'll have a mixed pixel which has a bit of everything. So we would be guessing. So the AI models we use, they learn both from patterns and color. So the way we'll be dealing with this is we'll have a specific peatland condition matrices in specific locations, and then we'll be drawing the polygon around this with the same texture and color. And we'll be telling, well, this is that with those predominant species, but we will not be going down to a specific coverage of specific species and the mixture. It will be more about sphagnum-dominated peatland in good condition, or tussocky area forum, bog, and then the condition measure for that. So we are still developing a translation between the condition matrix with about 70 classes to something much simpler, because we think the level of the number of condition levels should be much shorter to make it more uniform and also applicable in the UK. But it's a work in progress because we shouldn't compress it too much, so it still is useful. Yeah.
Thank you.
Awesome. Thank you, Olga.